Hello and welcome. In section 3, you'll be solving natural language processing challenges. And we'll start with the task of creating and compiling a convolutional neural network for sentiment analysis. And the dataset that we'll be using, you can find it inside the source directory for this section. It's inside the directory called review_polarity. And there's also text document with the link that you can use to download this dataset for yourself. But it's included in source directory, and your task is to design the convolutional neural network that can be used for sentiment analysis. So right now, pause the video and try to solve this problem, and in a moment I will walk you through the solution. So good luck, and I'll see you in a minute. Okay, welcome back, and let's have a look at the solution. And instead of just jumping into the actual code, I would like to give you a high-level overview of the solutions. And actually, I would like to break down the solution to a bunch of questions that you might ask when analyzing this kind of problem. So the first question that I would ask is that what kind of data we're working with here? Because as you probably know, your first intuition, or at least my first intuition about convolutional neural networks, is that they are used for image processing, okay? And after analyzing or looking at the data, okay, we have a text here. So this is the first distinction, okay? What kind of data we are working with here with text. Then the next question, okay, so the common use case for convolutional neural networks are images. And is there any way that we can use text data with convolutional neural networks? And the answer is, of course, we can use a word embeddings, and specifically in Keras, we can use embedding layers, which will train those embeddings. And those are simply vectors comprising of words that can be used with convolutional neural networks. Then the next question would be, okay, so this is a convolutional neural network that we can use with text, and what should I add inside my hidden layers? How my hidden layers should look like. So hidden layers, or those are the main layers inside our network. And the answer to that is that when you look at convolutional neural networks in general, then you usually have a bunch of convolutional layers and also some kind of pooling layer. And in this particular problem, we are working with vectors, one-dimensional data sets. So we'll be using one-dimensional convolutional layers, and we'll be using max pooling, because in this case, we want to choose the best possible embedding or the best possible phrases that we've got out of the training. In this case, in our hidden layers, we need to have some kind of a convolutional layer, also some kind of pooling layer. And the details later on, you can test it, but we have to have the general idea of what's need to be inside our convolutional neural network. Then the next question is, what output am I looking for in sentiment analysis? So I hope that you've looked at the dataset and you've realized, or maybe you knew, that sentiment analysis is all about pretty much it's a classification problem, and we have just two classes. We want to classify a given text as negative or positive. So this is our main task, to classify a given text as negative or positive. So we have those two classes, and what kind of output should our network have, or should my network have, and how should I encode it? And since we have only two classes, we can just encode it as 0 or 1. Then the next set of questions are all about, okay, we have this general architecture, then we need to compile our network, and to do that we need to pick and choose the loss function. Also, the loss function is important because it has a good match or perfect match for our problem. So here we are dealing with two classes and with classification problem. So we have binary underscore cross entropy. This is the loss function that is always used when you have just two distinctive classes. So this is kind of a default answer when you have just two classes. And then we will also have to pick up an optimizer. And if you have some experience with machine learning, you probably have your own pick. But my default pick for most use cases, unless I don't know something specific about a particular use case, is always to use an algorithm. Because this is the most general, in my opinion, algorithm to work with most machine learning problems. And then the last question, which is kind of optional, but it's useful to ask that, what kind of additional metric can I actually use in this training process? And here we are working with classification problem, so we are interested in accuracy, so we can measure that. We can measure the accuracy of our classification. So let's now jump into the actual code and see how it's done inside the code itself. So here's a solution1.py. This is our script that implemented those ideas. And there are a couple of more details that you have to know to actually create a working script. And the first piece of information that is really important in this particular challenge is how to configure the embedding layer. So embedding layer is the first layer that we have to have in our network because it has to produce a vector that can be used, or word embedding that can be used with our convolutional neural network or convolutional layer that we have. And to properly configure our embedding layer, we need to know a few things. First, we need to have our vocabulary size. So the number of unique words that our data has. And we don't have those informations yet, so we have to create a function or some kind of mechanism that will allow us to set this value. And this is the first argument for our embedding layer. Then the last argument is the maximum input length, which is also very important, especially in this particular case. I think this is actually required when we are using the dense layer and the end. And we're using flatten and also dense layer, those two layers at the end. If we use them in this kind of configuration, we need to specify max or input length. And in our case, this is a maximum number of words in a sentence. And in our data set, we have just a reviews, right? So those will be the maximum number of words in a review. And then again, we have to leave it as a variable because we'll have to analyze our data set and then provide those kind of information. And the last piece of information is the dimension of our output embedding. So what kind of vector should our embedding layer produce? And there's no good answer to that. You have to experiment with that. I've set it up by default with a bit of experimentation to 25. And there are different kind of sizes that you can use, but then I highly encourage you to test it out to try out different options. Then after configuring our embedding layer, let's just jump in at the end of this network for a moment, because we've started our analysis with inputs and outputs. So in our output, we are using just sigmoid activation function. This is our dense layer with just one neuron. And this means that we can present two states, 0 and 1, which is exactly the two classes that we need to encode using this layer. So those are inputs and outputs of our network, and those are based on those ideas that we've done in this high-level analysis. And then inside our network, we have those then one-dimensional convolutional layer and also max pooling. And the parameters here, again, have to experiment with them. There's no any ready-to-use recipes for convolutions and for max pooling. The usually starting points are the articles or research that some other people have done or just experiments. So I won't go into the details into how to go about figuring those hyperparameters, but just keep in mind that it's all about experimentation. And then after having those convolutional layer and also max pooling layer, we need to do one more step before we can actually train our classifier, we need to use a flatten layer so we can produce just one vector that can be used with the last dense layer, right? So this is the implementation of those ideas for this challenge. Then the last step is to compile our model, and here we just picking and choosing binary cross entropy for this particular problem because this is binary classification problem. We've chosen optimizer called Adam, and then again here you can choose, you can have some kind of your favorite optimizer, and my advice is that as long as you get the results that you want to get, that's fine. But I found that Adam Optimizer is pretty great first choice. And then we also provide the accuracy metric, the additional metric for this model, so we'll have an additional metric to look at when we will be training our classifier.